So, in this class, we have discussing the new chapter introduction introduction to non-ferrous binary systems. In this, we have to learn the learning objectives, the copper zinc equilibrium diagram, explaining about copper zinc equilibrium diagram, and different classifications for gases, and we deeply discuss with alpha plus beta process, Munju metals, with ice, and what are the difficulties, what are the problems arise during using the brasses, the copper alloys in different applications. The things how to discussed in this class. Mainly, the metallic materials is broadly subdivided into two large groups. There is the ferrous metals and the non-ferrous metals. The ferrous metals we have already seen, and non-ferrous metals, that is copper, aluminum, zinc, tin, tungsten, etc. These materials other than iron are all the concentrated non-ferrous metals. So each and every non-ferrous metals shows has its own metallic properties and in different applications. These non-ferrous metals are those who do not contain significant quality of iron or iron as. The base metal, this metal possesses low strength at high temperature, generally suffer from hot shortness and have more shrinkage than ferrous metals. They are utilized in industry due to following advantages. Because the non-ferrous metals are popular, it shows the specific advantages of non-ferrous metals. It shows the high corrosion resistance, easy to fabricate, there is machining, casting, welding, forging, and rolling. And also it possesses very good thermal and electrical conductivity, and attractive color and a low density. The various non-metals used in industry, there is copper, aluminum, tin, lead, zinc, and a nickel, etc., and their alloys. These metals used in popular because of these advantages. The most, apart from that, all the non-ferrous metals, the copper is more useful and different applications. These alloys are used in different uses. So that's why I learned from non-ferrous metals the first copper and their alloy system. The copper is occurring in a negative form is called native copper. The copper is an industrial metal, is widely used in alloyed and unalloyed conditions. The crude of copper extracted from its ores through series of processes containing 68% of purity is known as blister copper. By electrolyte refining process, a high pure is 99.9%. The copper which is remelted and cast into suitable shapes, copper is a corrosion resistant metal of an attractive reddish brown color, used in different applications. See the copper which is in reddish and brown color and native copper. It observed through this microstructure of pure copper. The pure copper is used. This see how that blister copper shows like this. Main why the copper is popular because shows different properties that high electrical conductivity, high thermal conductivity, high corrosion resistance, good ductility and malleability, and a reasonable tensile strength is obtainable in pure copper. The copper used in different applications, that is the copper trolley wires, electronic products, copper plating, and a copper finish parts, and also used copper coins and a copper wires used in electrical sockets. The most used in electronic industry because it shows high electrical and thermal conductivity. These are important copper alloys are brasses and bronzes. The alloys copper and zinc is known as brasses. It is also known as copper zinc alloys. The copper zinc alloys is to show an alloy of brasses. The copper has alloy containing up to 12% of alloying elements other than zinc is known as bronzes. If copper alloy with tin is known as tin bronzes. Copper is alloy with silicon bronzes, and aluminum bronzes, beryllium bronzes, and the copper nickels, the alloy of copper and nickel. It is also nickel silvers, nickel and zinc is alloys. This is broad classification of copper zinc alloy system. So the classification of brasses, the alpha brasses are hypoperitectic alloys containing up to 36%. The structure containing only alpha structure. The alpha structure, there are two types of alpha brasses. Yellow alpha brasses, that is 20 to 36% zinc. Red alpha brasses, that is 5 to 20% zinc. Alpha plus beta brasses, that means hyperperitectic alloys with alpha plus beta two-phase structure. The containing more than 36% zinc. That is known as alpha plus beta brasses. The copper zinc equilibrium diagram. To see here the copper zinc equilibrium diagram. The pure copper, it is melting point 1083, and at the zinc melting point, this diagram it shows up to 50% of zinc soluble in the pure copper to form copper zinc equilibrium diagram. Say more than 50% because if the zinc is dissolved in a copper, it has become brittle. Alloys are formed. So more than 50% of zinc is not useful in applications. So that you have learned up to 50% zinc of the phase diagram you have studied. In this diagram of an equilibrium diagram to show that the liquidus line on the top above the liquid is the liquidus line, the solidus line are observed the diagram, and more number of peritectic reactions and eutectic reactions are in phase diagrams form. and the single phase regions, liquid, both the liquid line, and a solid single phase solid solutions, so that is alpha, beta, and the two phase regions, alpha plus liquid, beta plus liquid, and alpha plus beta, the solid phases. This is the two phase region, that is single phase regions. And also that is alpha maximum up to 36% of zinc dissolved in a pure copper to form alpha solid solutions. Did alpha to show maximum ductility and the strength value. If more than 40% of the zinc added to the copper, the zinc alloy, the copper zinc brushes become its brittle in nature. Hard and brittle compounds are formed. It is not used for applications. So that after alpha, up to 36% of a zinc dissolved in a pure alpha to form different brushes. Up to 40% zinc is dissolved to form solid solutions, that is the alpha plus beta brushes. If more than 40% zinc is not used for applications. So that alpha plus beta brushes used in some applications, and at a higher temperature to form alpha plus beta at 450 degrees. The alpha beta change it to alpha plus beta prime structure at room temperature. At below 450 degrees centigrade, the alpha plus beta change it to alpha plus beta prime. That is alpha and a beta. That means copper and zinc atoms are arranged in a disorder in the solid state. While at 450 degrees centigrade onwards, the disordered atoms are arranged in a ordered form. So ordered solid solutions are formed below 450 degrees centigrade. That's why the solid structure indicates alpha plus beta prime. And also the single phase solid solution, that is the terminal solid solution beta, at below 450 degrees centigrade is changed to ordered beta structure. These reactions are formed in copper zinc equilibrium phase diagram. In this phase diagram, the solubility of the zinc in alpha solid solution increases from 32.4% at nearly 675 degree Fahrenheit about 39% at 850 degree Fahrenheit. With the zinc addition exceeding the solubility limit, a second base beta is formed. The beta phase exhibits order and disorder transformations between 450 to 470 degrees centigrade. The ordered phase is in a designation as a beta prime. Because an alpha as FCC structure solid solution and beta as BCC structure electron compound. Thus the peritectic reactions occur in copper zinc equilibrium phase diagram. The peritectic reaction occurs at 657 degrees centigrade. The reaction liquid gives rise to liquid plus solid gives rise to new solid. That is, liquid plus alpha solution gives rise to beta intermediate phase compound. Similarly, other peritectic reactions takes place above more than 50% zinc dissolved in copper. The peritectic reactions occur to form single phase compounds. These compounds have ordered structures are formed. Basically, the alpha brushes containing up to 36% zinc. In case red alpha brushes is 5 to 36% zinc is known as red alpha brushes. These red alpha brushes are used in different types depending upon content of zinc allied with copper. It is 95% of copper, 5% of zinc is known as gliding metal. The gliding metal is used in coins, tokens, and fuse caps. This is one type of red alpha brasses. The next one is 90% of copper, 10% of zinc. This is known as commercial bronze. The commercial bronze is used in custom jewelry, forgings, and rivets. Yes. And 85% copper and 50% zinc, that is known as red alpha brasses. The red brasses used in applications, electrical conduct, sockets, and hardware. Equipments are preferred. And 80% of copper, 20% of zinc. It is known as nearly low brasses. Low brasses means that the content of zinc is a little bit higher. The low brass are used in applications are medallions, musical instruments, and deep drawn articles. Deep drawn articles, that means musical wires for a guitar, veena, and other musical instruments. Medals used go like bronze medals for athletics. Winners is represented by medallions, bronze medals, and also used deep drawn products. Thus, red alpha brasses is nearly 5 to 36% of zinc. Tisa in pure copper is known as red alpha brasses. These red alpha brasses, the next one is yellow alpha brasses. That is yellow alpha brasses is nearly 30% of zinc, 70% of copper. Is known as cartridge brass. Cartridge brass 70% copper, 30% zinc is known as yellow alpha brasses in one variety. It is used in headlight reflectors, and condenser tubes are manufactured with cartridge brasses. The next one is yellow alpha brasses, again admiralty brass. The admiralty brass, the composition is 71% copper, 28% of zinc, and 1% of tin. That is called admiralty brass. It is mostly used in heat exchanger tubes. And the third one is alumina brass. The alumina brasses are 76% of copper, 22% of zinc, and 2% of alumina. Composition: alumina brasses is used in marine equipments and land power stations applications. This is more popular in marine and land power stations of alumina brasses are used. These is applications and the types of yellow alpha brasses and red alpha brasses. These are different types of brasses used in different applications. The microstructure of some types of brasses, that is commercial brasses. The commercial brass is contained, that is alpha structure of pure alpha structure and little amount of zinc. And also cartridge brass, that is the 30% of zinc dissolved in pure copper. The cartridge brass, the structure of alpha and beta structures in cartridge brass. Both the microstructures are observed in some types used in alpha brasses. And other variety is high tensile brasses. The high tensile brasses The alloying elements such as aluminum, iron, tin, nickel are added to 60 to 40% brass to increasing its tensile strength. The brass containing one or more of the above elements are called high tensile brasses. These high tensile brasses, to show these properties, the alloy can cast well as hot worked. The good resistance to seawater corrosion. That means good corrosion resistance. And the tensile brasses are good tensile strength is nearly 40 to 55 kg per mm square. And also detail elongation, that is the ductility 20 to 30%. This shows the good mechanical properties can withstand the tensile brasses. The tensile brasses composition: manganese 1%, iron 2%, the zinc 39%, remaining copper used for manufacturing of high tensile brasses. These high tensile brasses are used in applications in a different, that is the engine pumps, the pump engines are manufacturing, marine propellers and gears, locomotive axle boxes, gun mounting and sights, and also water turbine runners, automobile fittings. These are the applications of high tensile brasses. The properties, composition and applications of high tensile brasses. The next one is alpha plus beta brasses. The alpha plus beta brasses means the containing 36 to 45% of zinc, and a remainder is for copper for hot working applications. The tensile strength and ductility of brass both increasing with increasing content of zinc up to 30% zinc. With further increasing the zinc content beyond 30%, the tensile strength continuously increasing up to 40% of zinc. But ductility of brasses drops significantly, and the beta phase is less ductile than alpha phases, but it is harder and stronger as fresh diagrams. Case of alpha plus beta brasses, there are various variety types of brasses depending upon the proper proportion of copper and zinc. Fundamentally, brass is a binary alloy of copper with as much as 50% zinc. The various classes of brasses such as discussed are cartridge, munch, leaded brass, admiralty brass, novel brass, nickel brass, and depending upon the proportion of copper and zinc class, the third alloying metal are available for various uses. The suitable type of brasses can undergo the process of casting, hot forging, cold rolling into sheets, drawing into voids, and extrusion for obtaining requisite special cross-section bars obtainable in specific applications. That's alpha plus beta brasses. This melting point of these brasses varies according to its composition, but most of the brasses in a common range. They liquefy between temperature of 840 degrees centigrade to 960 degrees centigrade. By adding very small quantities of other elements, the properties of brass may be greatly affected. For example, the addition of 1 to 2% of zinc improves the machinability of brass. And also, the brass has a greater strength than that of copper, but has a lower thermal and electrical conductivity. The brasses possess very good corrosion resistance and can be easily soldered by using this alloy of steels of bronzes. These brasses are used in hydraulic fittings, pump linings, utensils, bearings, and brushes. These brushes are used in different applications. So that's why it's more popular, these brushes, in applications. These alpha plus beta brushes, it shows the properties are very high tensile strength, hard working properties, and a good forgeability. The alpha beta braces are used in applications, architectural works, brazing rods, and valve systems. These are main applications of alpha plus beta braces. These alpha plus beta braces, that is the microstructure of alpha plus beta braces. See that hard-rolled mingy metal sheet structure of beta phase and alpha phases. The dark region is beta, the light region is alpha. The cast structure shows the dendrites of alpha in a matrix of beta. The alpha structure, which is a light white color, in the matrix of beta, that is the dark fields. And the 40% of zinc provides the complex structure of alpha and beta phases. So that is beta phase makes this alloy heat treatable. That is alpha plus beta brasses are used in applications with the required strength and reasonable toughness are shows. The microstructure of alpha plus beta brasses. The cast structure is consists of flakes of both alpha and beta grains. When it is subjected to hot rolling, a disintegration of beta phases takes place. This is very clear in the microstructure. The discontinuous beta network is distributed throughout the solid solution is uniformly. That it stands high strength and reasonable ductility is obtainable in case of alpha plus beta brasses. And these alpha plus beta brasses at 450 to 470 degrees centigrade. The ordered structure of alpha plus beta, disordered structure of alpha plus beta changes to ordered structure of alpha plus beta brasses. Eventually, it takes place. And the next one is what type of alpha plus beta brasses is Munch metal. It is most widely used alpha plus beta brass, having composition is for 60% copper and 40% zinc. So zinc 40% and 60% copper is known as Munch metals. The Munch metal sheet shows very high strength, excellent hard work properties. In this case of alpha plus beta brasses of Munch metal, the rapid cooling follow. The beta prime region may suppress the precipitation of most of the alpha phases. The hinge metal is heat treated and suddenly cooled at that particular temperature. The beta phase is suppressed and most of the alpha phase are there. So high ductility, obtainable and its reasonable strength is obtainable in Munch metals. The Munch metals used in applications is used as a sheets for ship sheathing, condenser heads, perforated metal works, architectural works, valve stem, brazing rods, and condenser tubes for applications of Munch metal. The leaded Munch metal having 0.4 to 0.8% of lead has improved machinability for alpha plus beta brasses for the Munch metal. So better machinability obtainable if a little amount of lead added to the Munch metal. See the crystal structure of the microstructure of Munch metals. The Munch metal, why it is called Munch metal? We have observed that tate fruit, the cut over at the head part, the tate fruit to show like a eye-like structure, bullseye structure likes. That's why the name is called Munch metal. The structure look like this. Before heat treatment electron microscope, see the curled microstructure of Munch metal, and under microscope we observed Munch metal microstructure, that is alpha plus beta structure. More amount of alpha distributed uniformly in solid solution. Almost the beta is suppressed at good reasonable strength values of alpha plus beta microstructure, that is Munch metal. The Munch metal shows this structure. The season cracking or stress corrosion cracking. Usually these alpha brasses are in different applications. It is suffered with some difficulties because of bad environmental, and these brasses are subjected to during manufacturing or a cold working process. The severe stresses are induced. The problems may be arised. In that processes, the main problems are season cracking or a stress corrosion cracking is a problem of especially the yellow alpha brasses. These yellow alpha brasses, especially 20 to 36% of zinc, have good strength and with high ductility. These brasses are suitable for drastic cold working operations. The highly stressed brass may be sensitive to failure by cracking in a service under conditions of corrosive nature. The stress makes the brass more susceptible to intergranular corrosion, particularly in an ammonia atmosphere. This failure is spontaneous and may occur without any added strain from service. Already induced stresses are kept inside that process during service conditions around the atmosphere, especially the taboria or corrosive atmosphere, affecting that these cracks may develop during service conditions. Once a crack is initiated along the grains, these travel along the grain boundary and reaches, and finally the stress applied to reach at any time may fracture of the particular process. So the failure is spontaneous whenever and occur without any severe strains from the service. The spontaneity don't expect it when the material fails in that. So you have to take care during seasoning period. The corrosive atmosphere, the corrosion attack the particular places to cracks are developed along the grain boundaries. The season cracking array stress corrosion cracking is the best remedies to remove internal stresses before use of brasses. The brasses were subjected to any applications. Before that, we can remove that what are the stresses are induced during cold working process. And the second one is low stress relief annealing treatment. Especially the yellow alpha brasses are subjecting to annealing treatment up to 400 degrees Fahrenheit. At that heating temperature during cooling, these internal stresses are removed once subjecting to this treatment. Then is directly used in applications. And also thirdly, the substitution of less susceptible copper alloys will minimize the danger of stress corrosion cracking. The substitution of less susceptible copper alloys. So that is we take before brasses manufacturing process. That is the remedies. See the stress corrosion cracking or a season cracking. The stress corrosion cracking and a season cracking, it is a combined action of corrosive environment and mechanical stresses, which is often due to poor design or pure maintenance practice. The season cracking or a stress corrosion cracking then occurs. The stress corrosion cracking is also SCC is an intergranular corrosion of metals caused by stress and corrosion. The combined effect of stress and corrosion at in yellow alpha brasses. The stress corrosion crack, how the crack propagated along the grain and grain boundaries. At the grain boundaries to follow like a snake walk, the crack initiated and propagated along the way of snake movement to one to other side. In above the figures to observe that the stress corrosion cracking or season cracking. As in dangerous without any indication, the material simply fails from the solution. So that to where the stress corrosion cracking and a season cracking are in yellow alpha process. This problem should be remediable before used in services. How the brushes blades are corroded. Along this, what's the crack initiated interior body of the base metals? But during the effect, the corrosive atmosphere attack on the brass plate, how the fracture takes place on that particular brasses. See the clear figure of intergranular corrosion or a stress corrosion cracking in brasses. The stress corrosion cracking occurs in brasses containing more than 50% zinc and appears at a grain boundaries. There is an intergranular corrosion along the structure of alpha plus beta. The intergranular stress corrosion cracking in a cartridge brass that is 70% of copper, 30% of zinc due to exposure to corrosive atmosphere. This corrosive atmosphere shows how the stress corrosion cracking is taking place along that brass materials. And another one problem is dezincification. Again, these yellow alpha brasses are subjecting to pitting corrosion. Pitting corrosion, this is called dezincification. It occurs when brass is in contact with the seawater or with the fresh waters that having high content of oxygen and carbon monoxide. Especially these yellow alpha brasses contact with the seawater, that is chloride water, or with the water containing high oxygen and carbon monoxide. This dezincification takes place, or it is also known as pitting corrosion. The pitting corrosion, that means it involves dissolution of the alloy and subsequent deposition of porous and non-adherent copper. So deposits, the porous non-adherent copper are formed on this. It is eventually penetrate the cross section of the metal unless it is stopped. Once it is not stopped, it is easily penetrated into the interior body of the yellow alpha brasses. And once the interior section, these try to penetrate, is lead to leakage through the porous copper layer. Non-adherent copper porous layer is broken by this chloride atmosphere or other high oxygen content gases may attack on this. The porous layer break and a leak is into this interior body of the brasses. That's too the content of zinc decreases. This is known as pitting corrosion. Mainly the dezincification occur in this mostly red alpha yellow alpha brasses, especially 15 to 20%. So the substantial degentrification may occur. Less than 50% is not there. The ease of manufacturing and the cost effectiveness are obtainable because of only more than 15% that alpha brasses, that is yellow alpha, and that is the alpha plus beta brasses, and the beta brasses also have to see this between corrosion. The degentrification of alpha phages inhibited for small additions of arsenic and tin to brass alloys. In case of alpha phages, the pitting corrosion degentrification is easily controlled simply by adding light amount of arsenic or tin. The tin and arsenic are helpful to inhibit the degentrification porous because the copper porous becomes non-adherent and there is no chance to penetrate these contents, and also uses that EG of manufacture cost effectiveness. This is the diagram to know easily how the red alpha brasses, yellow alpha brasses subjected to degentrification process. There are two types of degentrification process. There is a uniform type. It is uniform type, a layer type for degentrification results in a relatively uniform zone of zincified materials, with underlying materials remain unaffected. Brassage with high zinc content in acidic environment is highly prone to uniform degentrification. The degentrification layer is formed on the surface of these metals. The uniform layer degentrification. This is simply uniform or layer type selective leaching subject to this to void. See, in a particular type of metals, degentrification, the zinc content or evaporate and the copper fatigue corrosion fracture takes place. The remedy for degentrification, the small amount of tin and antimony minimizes degentrification in yellow alpha brasses. That is the best solution to voids. So that is all about copper alloys, especially in brasses. In the next class we have to discussing about copper tin, that is bronze alloys.